All right, so we've got one problem in this video. We're taking the integral from 0 to pi over 2 of 1 over x sine of x dx. Now we should recognize this as a type 2 improper integral because the sign of 0 is 0, making a vertical asymptote at x equals 0. So how are we going to figure this one out? Well, let's just take a peek at the graph. Notice there's that vertical asymptote at 0. Pi over 2 is going to be what? About 1.5-ish or so. So we're going from here to that vertical asymptote at 0. So just like we did a comparison test with our type 1 improper integrals, we can do the same thing if we can pinch or squeeze it. Now, I think it's natural on this one, because there's a 1 over x in it already, is to compare it to 1 over x. Now, we have to recall, is this convergent or divergent, 1 over x? So 1 over x is underneath. It's between the function that we're trying to determine and that vertical asymptote. Okay? Is 1 over x divergent? If it is divergent, then the green one also has to be divergent. Okay? However, if the 1 over x is convergent, it doesn't tell us anything about our green function f of x. Now, this one you might not recall, and I'll be honest, I'm not quite as good at remembering my type 2 improper integrals. So let's just determine if 1 over x converges or diverges as a type 2 improper integral. So let's do a little bit of side work over here. Let's take the limit, okay, of an integral, and let's not go use pi over 2. Let's use pi over 2. Pi over 2 to, now we can't put in 0 of 1 over x dx because 0 is a vertical asymptote. So remember, we evaluate the improper integral by changing where the vertical asymptote is to a t, and we're going to take the limit as t goes to 0 from the right. So, how do we do this? Well, this is going to be the limit as t goes to 0 from the right. What's the antiderivative of 1 over x? Well, it's the natural log of the absolute value of x. Now, I don't need the absolute value of x because we're only looking at x's to the right of 0. So I'm just going to go like that. We're going to go from t to pi over 2. So now let's substitute in our pi over 2. So it's the natural log of pi over 2 minus the natural log of t. Now, when we take our limit, the limit as t goes to 0 from the right of the natural log of pi over 2 is just the natural log of pi over 2. That's just a constant. Minus. Now, what's this limit as we go to 0 from the right of the natural log of t? Well, what's the graph of the natural log look like? Well, we know the graph of the natural log function looks like this. And as we go to 0 from the right, it goes to negative infinity, right? So this does not exist. So this integral diverges. So that's a good news for us, because when we look back at our graph, if 1 over x diverges, then 1 over x sine of x also has diverged because it's outside of a function that already diverges. That's good news for us. It tells us this one also diverges. So what are we going to say here? The integral from 0 to pi over 2 of 1 over x dx diverges. 1 over x sine of x is greater than or equal to, because it's above it, 1 over x on the interval 0 to pi over 2. This should be a parenthesis because we can't actually have 0. Okay. So the integral from 0 to pi over 2 of 1 over x sine of x dx also diverges. So we could do the same thing that we did with our type 1 improper integrals if we want to do comparison tests with our type 2 improper integrals. Just compare it to one that you already know. And if you don't already know one, you can do a little side work over here and just pick an easy one and determine if it converges or diverges, and then set up your comparison. All right, thanks for watching. We'll see you later.